In other lessons on study strategies, we made mention of retrieval practice as one of the best practices. In this lesson, we'll take a look at some of the evidence that retrieval practice really is a good study technique. Now, if you ask students out there today what kinds of study techniques they use, a lot of students say they do something like restudy or reread their notes or whatever information that they have to master. So the restudy, reread technique is very common. Now, the choice to restudy makes sense if students think of learning as getting the information into the mind, what psychologists call encoding the information or constructing knowledge. But this approach overlooks the importance of retrieving the information when we want it. It's not enough to just get the information into the brain. We want access to it later. Now, while some students do use self-testing, they often think of testing as a procedure to measure learning, not a learning technique itself. So again, in this lesson, we'll look at the evidence that retrieval practice enhances learning, and therefore is one of the best practices we can use. So how would we test the effects of retrieval practice? Well, consider this simple experiment. Suppose we have a couple of groups in our experiment. Group 1, the students study a text for the main ideas. Group 2, the students study a text for the main ideas and then take a practice recall test right afterwards. Both groups are tested 1 week later, and what you find is Group 2 does better on the final test. So that suggests that the recall test right after the study session is having a positive impact on retention 1 week later. But was the result due to the influence of retrieving information during the practice, or might there be some other explanation? As it turns out, in this kind of experiment, then we have two variables. So the students who studied and took a practice test performed better on a test 1 week later compared to the students who only studied. But we've got two explanations. Retrieving information might have caused the result, but the retrieval group also spent more time processing the information. Perhaps the extra processing caused the result. So this is not a well-designed experiment because there are two differences between the groups. There's the difference of retrieval, the recall test, and the difference of the amount of time the students were processing the information. So how can we prove the experiment? With an experiment like this. Group 1, read the text material in 4 study periods. So we're going to call this the study group. Group 2, read the text material in 3 study periods and recalled as much information as they could in 1 retrieval period without restudy or feedback. Notice then the amount of time spent processing will be the same in groups 1 and 2 and in group 3. Group 3 read the text during 1 study period, then practiced recalling it during 3 consecutive retrieval periods without restudy or feedback. We'll call this the study, retrieve group. Again, we are making sure that the groups are spending the same amount of time processing the information. The difference is the extent to which there is any retrieval in the mix. All groups made judgments of learning, which is a prediction about how well they would remember the material 1 week later. Let's first take a look at these judgments of learning. This graph shows the predicted recall of the information that they were reading. So judgment of learning here would be the extent to how confident they would remember the information 1 week later. And notice we have the highest predicted rates of recall for the folks who were in the study group. Lowest predicted recall when there was more retrieval in the mix. So students thought they would remember the information better if they were in the study group. Let's see what the actual results were. The actual results were the opposite of what students predicted. The best recall was seen in the individuals that studied the information once and then practiced retrieving that information 3 consecutive times. Now, what they're actually measuring here for the y-axis, the proportion of ideas recalled, so whatever information they were reading, the researchers would identify however many important ideas are in the text, and so here we have the proportion of those ideas that were in the whole text, the proportion that was recalled. Notice again, the study group actually had the worst recall 1 week after reading the information. The more retrieval, the better the recall after 1 week. And this is opposite of what's predicted. So it's looking like students have fairly poor meta-cognition in an experiment like this. They predicted they would recall more from the study condition, when in fact they recalled more in the retrieval condition. Now, why would that be? Well, a clue comes from another study. Consider this scenario. Group 1, they read the text material for 7 minutes, do a distracting task for 2, then reread the text for another 7. Call that the study group. Group 2, read the text for 7, distracting task for 2, and then recalled as much information as possible. So again, the retrieval task. So again, I just have a blank piece of paper and just write down as much as you can remember from what you just read. Groups 1 and 2 were tested at 3 different retention intervals. 5 minutes, 2 days, and 1 week. So here now, it's the same kind of design where you have study versus study test, but now we're looking at retention intervals and changing up the time between the study and the testing conditions. So let's take a look at what happened. First, when the retention interval, that is the time between the studying and the testing, was 2 days or 1 week, we see superior performance of the students in the study test condition. So again, it looks like retrieval practice, retrieving information, is showing benefits when the test is 2 days or a week later. And that was similar. So this is a replication of this other study that we just saw a moment ago, where the study group had poorer memory 1 week after reading the information. But what happened when the test was 5 minutes after the study session? Here we see something interesting. Notice the study group outperformed the study test group. It's not by a lot, but still, they did well, and a little bit better than the study test group. So here we see an intriguing phenomenon here. The study condition shows benefits at short retention intervals, but the study test condition shows benefits at longer retention intervals. So to summarize then, after 2 or 7 days, the study test condition showed greater recall. And here we would explain this by noting the benefits of retrieval practice for long-term retention. Whereas when tested 5 minutes later, the study condition showed greater recall. And we'll call this the cramming effect. Now, students may overvalue the restudy strategies, and this may be why it is so common that students do the restudying, because they do them prior to tests, and there are evident short-term gains. Right? So when students restudy, they often do it right before the test, and so then they see a bump in their performance, and they think the improvement was due to the restudying approach. So cramming does make recently reviewed material more easily accessible in the short term. However, long-term learning is best achieved by a testing strategy. We can use our analogy with the computer to understand this a little bit better. So it appears that the study condition makes information readily available in the short-term memory system, the RAM of the computer, whereas the study test condition more effectively stores the information in the long-term memory system, the hard drive. Now, if we want to be educated, of course, we want to be storing information in the long-term memory system so that we have access to it for the rest of our lives. These results highlight a misconception that many students may suffer. During a study session, students may believe that the ease of retrieval during a study session is a good measure of the long-term storage of the information, and that's false. Ease of retrieval is likely the result of recent processing, what we have called in other lessons the working memory boost. Ease of retrieval is only a good measure of long-term storage if used after a delay. So we have to remember the short-term memory system is different from the long-term memory system. Another way to think about this is to think of the illusion in the following way. We use recognition as a measure of knowledge. When we reread text or notes, the information becomes more familiar, which leads to the perception that understanding is high. But familiarity is not the same as the ability to retrieve. Understanding something is not the same as remembering it later. So the judgments of learning made by students are often overconfident, and we stop studying too early. Now, there is a better way, and it is the active retrieval, the retrieval practice. Active retrieval changes the information the brain uses to assess knowledge. And so now judgments of learning are based on the ease or difficulty of retrieving information. And that has to be without text or notes present. And this is a measure that better predicts future performance. So retrieval is going to better predict future performance, because what we really want is the ability to retrieve the information. It's not enough that we are familiar with the information, or we recognize it, or we think we understand it in the moment. Importantly, retrieval attempts should be delayed so that the working memory boost during a study session is no longer in effect. So we want to use retrieval, and we want to use it after a delay in our studying. Then the ease of retrieval is a good measure of long-term storage. Finally, consider another study, and here we'll see the effects of repetition. Group 1, students read a text once. Group 2, they read a text once and recalled as much as possible, followed by brief rereading. Group 3, they read a text once and had repeated recall restudy sessions for a total time of 30 minutes. All groups were tested 1 week later. The results were clear. With repeated retrieval practice, you get significantly better retention of the information 1 week later. So again, you just study. You study and retrieve once. You do the retrieval repeatedly, and the benefits are clear. So retrieval practice does take time, but it's worth it. It shows significant enhancement of retention at longer durations. So we want to think of tests as learning instruments. Tests are learning opportunities, not simply assessments of prior learning. And students and teachers may be discounting the benefits of testing on memory if they just use them to assess prior learning. Now, students do sometimes use self-testing, but often at the end of study sessions, thus missing the benefit of testing. What we want to do is get as much of that retrieval practice in the mix during the study sessions, because by retrieving the information, we're helping the brain store that information. So tests are not just assessing prior learning, they are helping us learn the information in the first place.